This is 4.5 Rational Functions, Day 3, working with slant asymptotes. The slant asymptote will be addressed in the second example here. First, I'm going to do another graphing example, just like in Day 2, where we need to find the x and y intercepts, the vertical asymptotes, the horizontal asymptote. We're going to test for the behavior near the vertical asymptotes. So here we have the rational function r of x equals x squared plus 3x over x squared minus x minus 6. And what we're going to do is follow the steps from Day 2. So the first thing we need to do is factor this rational each polynomial. The numerator is x squared plus 3x. We have an x in each term. Therefore, we will factor out x, and we are left with x plus 3. For the denominator, we can use product sum rule, diamond rule, diamond method, or quad 3 on a graphing calculator if we have that. And we would get x minus 3 times x plus 2. The second step is to find the x and y intercepts. So for the x-intercept, we set the numerator equal to 0, and we're going to set both factors equal to 0. So we have x equals 0, and we also have x plus 3 equals 0, which gives us x equals negative 3. So those are the x-intercepts. And for the y-intercept, we are going to plug in the value of 0 for all of our x's. And anytime you plug in 0 into a term involving x, it creates a 0 for that term. So we get 0 plus 0 over 0 minus 0 minus 6, which is 0 over 6, which means y is equal to 0. So that is our y-intercept. And now on to step 3. Step 3 is finding the vertical asymptote, or multiple. And to do that, we set the denominator equal to 0. So we would get x minus 3 equals 0, and get x equals 3. And we would also set, this is the vertical asymptote, we would also set x plus 2 equal to 0, and get x equals negative 2. And for step 4, we are finding the horizontal asymptote, which is to compare the exponents of the rational function. So the numerator has a value of 2, the denominator has a value of 2, they are equal, and therefore we take the coefficients of each polynomial, which is 1 over 1, and we get y equals 1. And for step 5, we are going to be testing some kind of points possibly to help shape the graph. And I will do that later as needed. Okay? Now we also need to test some values for the vertical asymptotes. Since we have a vertical asymptote at 3 and negative 2, that means I need to test a value that is 0.1 units away from both of these asymptotes. And I only test for the vertical asymptotes, not the horizontal asymptotes. So my test points are going to be 2.9 and 3.1. Those are 0.1 units away from the 3. And 0.1 units away from negative 2 would be negative 1.9 and negative 2.1. I am going to start with negative 2.1 and go from left to right. And since I'm thinking about it, I'm going to go ahead and put my asymptotes in here. And nope, here we go. Okay, so we had x equals 3, So there's one asymptote, and x equals -2. And there's the other asymptote, and y equals 1. There's our horizontal. Okay, now I'm going to move this one over a little bit. All right, now I'm back to testing my values. So I'm going to work from left to right. So -2.1. Okay, let's get the normal blue pen here. Okay, now -2.1. When I test that, I can plug that into the original function if I want. Make sure that you put parentheses around the number before you square it, and also put parentheses around the numerator and the denominator. So if I'm going to plug this into the original function, I will get parenthesis and then another parenthesis, -2.1 parentheses squared plus 3x, oops, plus 3 times -2.1 with that parenthesis there. So we're grouping that as one whole value before we divide. And then we could put in the division of parenthesis and then put parenthesis for the -2.1 squared minus -2.1 minus 6, and then parenthesis to group the end, the grouping for the denominator. If you don't do that, you will run into problems where you should get a negative when it's giving you a positive on your calculator, or vice versa. You might be getting a negative answer when it really should come out as a positive. So you really got to make sure you put in these parentheses so that you're getting the correct value. Okay. If you're going to do this by hand, then I would recommend using the factored form, and you'll have -2.1 and then -2.1 plus 3. And so for right now we have a negative, and -2.1 plus 3 is positive. And for the denominator, we would have -2.1 minus 3, which is a negative, and -2.1 plus 2, which is still negative by 0.1. When we look at this, we have 3 negatives, which gives us a negative value. So at -2.1, which is to the left of that vertical asymptote, we will be, as we get close to that vertical asymptote on the left-hand side, we are going down. Now I'm going to test -1.9. And again, you can use the calculator. I'm not going to show you how to plug that in. Just plug it in the same way you did up here with those extra parentheses. Let's see, -1.9 is obviously negative, and -1.9 plus 3 is positive. For the denominator, -1.9 minus 3 is negative, and -1.9 plus 2 is positive. So here we have two negatives, which is a positive value. Now I will test 2.9. When I test 2.9, I get 2.9, which is positive, and then 2.9 plus 3, which is positive. For my denominator, I get 2.9 minus 3, which is still negative by, or which is negative by 0.1. And then 2.9 plus 2 is positive. So 3 positives, 1 negative. I end up with a negative. And finally, 3.1. I will get 3.1 which is obviously positive. 3.1 plus 3, which is positive, over 3.1 minus 3, which is positive, and 3.1 plus 2, which is positive. So these all turned out to be positive, which means it's a positive value. All right, so let's go back over to the graph and just kind of make some kind of notation like I did here, which direction we're going. So at negative 1.9 to the right of the asymptote, I'm going positive, so up to positive infinity. To the left of the vertical asymptote at 3, at 2.9, I'm negative, so I'm going down. And to the right of the asymptote, I'm going positive, so I'm going up. Okay, now let's plot our points on here. So I had x-intercepts at 0 and 3, and a y-intercept at 0. So x-intercepts at 0 and negative 3. Yeah, I might have said positive 3. So 0 and negative 3. My y-intercept is 0. So I've got a couple points here that can help guide my graph on the left side and also the right side. I'm going to actually test a point over here just to confirm that I don't go up. That's really close to that horizontal asymptote. So it might go up over the horizontal asymptote and then level out. So I'm going to test a point over here and make sure that it stays under. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's try negative 10. So I'm going to test negative 10. Negative 10 times negative 10 plus 3 over negative 10 minus 3 times negative 10 plus 2. Negative 10 plus 3 is negative 7 times 10 is 70. Negative 10 minus 3 is negative 13. And negative 10 plus 8, 2 is negative 8. And let's see, that was negative 13. That's going to give us positive 104. So 70 divided by 104 is it's a fraction. So it's less than the value of 1, which is really all I need to know. So it's going to be around 7/10. So right up in here. And so my graph does stay under that horizontal asymptote. So it's going to stay under here. So it's going to go down, go through that vertical or that point, and then go down. Okay, so that's it's you can have it a little bit more curved if you can, do the best you can. Okay, in the middle here I've got a point on the x-axis, and I'm going to be coming from the top of the left, and I got to go down through, make sure I curve through like a little bit of an S curve. So I'm going to be going down, and as I go through I'm going to curve and then continue on down to negative infinity. Now over on the right hand side I need a point. So I'm going to plug in the value, say 1, 2, 3, 4, 5. I'm going to test in 5. So over here I tested negative 10, and over here I'm going to test 5. So I'm going to get 5 times 5 plus 3 over 5 minus 3 times 5 plus 2. So that's 5 times 8, which is 40. This is negative 2 times 7, which is negative 14. And that's going to give me Um, let's see, 3 times 14, 12, that's 42. So about 2.8, 2.9, somewhere in that general area, negative 2.8 approximately. I'm just totally guessing the decimal value, but the whole point of this is that, wait, 5 times 5 plus 3. 5 minus 3 is positive 2. So positive 14. So that's positive 2.8. So the whole point is that it's larger than the 1. So if I'm going to graph this, it's an estimated point anyway. Oh, that's 2.8. So 1, 2, 3, 4, 5, and then 2.8. It's going to be around right here. And we're not graphing exact points here. Anyway, so we're getting as close as we can because it's a rounded value anyway. Anyhow, so now I'm going to go down. I'm going to go through that point, and then I will be leveled off and guided by the asymptote. So that's another example of just the graphing. Now let's look at slant asymptotes. So here, slant asymptotes is when your n value is greater than m by 1. And your n is the exponent on the numerator, the degree, and m is the degree of the denominator. So because there are no horizontal asymptotes in that situation, we can have a slant asymptote. But slant asymptotes only happen when n is greater than m by 1. So what we do is we follow the same steps from day 2 with the added step to step number 4, where you have to do division to find your slant asymptote. Since there is no horizontal asymptote, we'll find the slant. Okay? And to find the slant asymptote, we'll divide the two polynomials and use the linear quotient as the slant asymptote, and this will be graphed as a dashed line using y equals mx plus b strategy. So let's take this rational expression, x squared minus 4x minus 5 over x minus 3. We will factor this. Let me get the blue pen just to have the different color. Okay, so when we factor the numerator, we will get x minus 5 times x plus 1 over x minus 3. For step 2, the x-intercept is setting the numerator equal to 0. So both factors, x minus 5 and x plus 1. So we will get x equal to 5 and x equal to negative 1. For the y-intercept, we plug in the value of 0. So we get 0 minus 5 over 0 minus 3, which is negative 5 over negative 3. So y equals positive 5/3 or 1 and 2/3. For step number 3, the vertical asymptote, we are going to set the denominator equal to 0. So x minus 3 equals 0. We get x equals 3. And for our horizontal asymptote, we notice that n is greater than m, so no horizontal asymptote, which means, and it's greater by 1, so we have to divide and find the slant asymptote. So x minus 3 divided into x squared minus 4x minus 5. We ask ourselves, what do we multiply times x to get x squared? That would be x. Distribute the x times the x minus 3, we get x squared minus 3x. and we are going to subtract going straight down. That gives us 0. Negative 4x minus a negative 3 is adding the 3x to negative 4x to get x. Bring down the negative 5. X goes into x only one time. Negative 4 plus 3, oh, that's negative 1, x. So I need a negative 1 up here to get negative x. Distribute that to the 3, I get positive 3. I'm going to subtract going straight down. I get 0 and negative 8. So what I'm looking at is just the x minus 1. I do not need the remainder. So my slant asymptote is y equals x minus 1. Okay? And step number 5 are those additional points that I might need to help shape my graph. I also need to test the values of 2.9 and 3.1. When I plug in 2.9, I am going to get 2.9 minus 5, which is a negative number, 2.9 plus 1, which is a positive number, and 2.9 minus 3, which is a negative number. So two negatives make a positive. And also for 3.1, I will get 3.1 minus 5, which is a negative number, 3.1 plus 1, which is a positive number, and 3.1 minus 3, which is a positive number. All positives? Nope. Two positives and one negative. I get a negative answer. So now I need to put my asymptotes in and my points. Okay, so my vertical asymptote was x equals 3. My slant asymptote was y equals x minus 1. So what I'm going to do is use my strategy of graphing a line in slope-intercept form. So I start with the y-intercept at negative 1. I go down and I plot that point. And then I count up my slope, rise over run. My slope here is 1. So that's 1 over 1. Up 1 over 1. Up 1 over 1. Okay, and that is going to be my slant asymptote. Should be already set up. I'm going to do my best here to get through those points. All right, so I'll move it when I'm got this ready to go. So there is my slant asymptote. Okay, now I have points. I have my x-intercepts at 5 and negative 1. So 1, 2, 3, 4, 5, and negative 1. And I have a y-intercept at 1 and 2/3. 1 and 2/3. Right about there. Okay. And I tested the value to the left is positive, and I tested the value to the right of the vertical asymptote as negative. So I actually have points in both of these areas. Since I have nothing in here, okay, just like in your regular graphing with a horizontal asymptote, I'm not going to have a graph on the top of this area and on the bottom of the slant asymptote. It's only going to be one or the other. So I'm going to have my graph down here. So I will take this from down at negative infinity, go through my point there, and then be guided by the slant asymptote. Same thing here. I start here at positive infinity. So I will come down. I will go through my 2 points already graphed, and then I will continue down to follow that asymptote. And there's my graph.